Okay, percents. Remember, off and up mean we got to do something over here. The item's original price is $700. It is 40% off its original price. Find the new price. So off means we want to take our 100% and minus 40%. That's 60%. Divide that by 100, and that's 0.6. Okay. Divide it on your calculator. Okay, I know it because I've done it for so long. All right, now remember the formula, the equation. Blank times blank equals blank. So we have original. And this can be used to solve any kind of percent problem where the percent's going up or off or down or up or something. Original times percent equals new. So we have our percent, 0.6. Okay. Circle what you're looking for. That's X. So it says new price, so that's X. And then $700 is the original. Easy problem because you're just multiplying. Okay. You need to solve for X. Well, you already have X by itself. You just need to multiply 700 times 0.6, 420. Okay. That's $700, so it's $420. Generally with these off-ups, I usually use money. Okay, an item's marked up 10%. Its new price is $60. Find the original price. Okay. So we need to adjust our percent. We need to take 100 plus 10%, and that's 110%. Then divide by 100. 1.1. Okay, so blank times blank equals blank, and I know my percents here, and then it's original. The original is always multiplied by the percent, and the new's kind of over here by itself. So 1.1 is my percent, and we're finding the original price, so it'd be the X for original, and 60 is my new. So obviously we're not going to multiply because we don't know what X is. So we're gonna. I can't do the operation that I see, so I do the opposite of the operation I see, which is to divide. And you just put 1.1. So I like to connect the line, put 1.1, and then I divide 60 by 1.1. I get rather weird answer, $54. Now, if you're talking money, you want to put two numbers after the decimal. So that'd be $54 and either 54 or 55 cents. It doesn't matter to me. A lot of people just like to put 54 because that's what they see. 55 cents would be okay too. Not $55, but you can put 55 cents. Okay, an item's original price is $80. It is marked up 30%. Find the new price. Okay, so up 30. Okay, so it's 130%, and then divide by 100. 130 divided by 100 is 1.3. So again, I want to use my new percent I came up with in the equation. The original price times our percent equals our new. So I have my percent figured out. That's 1.3. Now let's circle the final sentence. What do you find? You're finding the new price. So that's your variable. In algebra, what we're trying to figure out is usually the variable. So it's X, and $80 is the original. Okay. Now I like these problems where I know what the original amount was because I can just go ahead and multiply. Okay, 80 times 1.3. It's pretty easy. That's $104. Okay, next, an item is marked 40% off. Its new price is $150, and we're going to find the original price. Okay. So 40% off, well, that would mean I would want to take 40 away from 100. Now you're like, why 100? Well, because 100 is your whole. That's your whole price. Well, you're taking away from that whole. You're only ending up with 60. I divide that by 100, and I guess it's 60 again, so it'd be 0.6. Okay, and we need to go to our changing in percents. So percent. That original, if you want to abbreviate, that's fine. And then new. So 0.6 is the percentage. Okay, now we want to circle what we're finding because that's a variable. If you don't know it, that's why we have a variable. That's the original price. So the X goes here, and then 150 goes here. All right, now obviously I can't multiply because I don't know X, so I do the opposite of multiply. So I connect those lines and just divide by 0.6, and you divide by 0.6. Now, for some of you that just kind of divide on your calculator, you don't really put that under it. I don't have a problem with that, but make sure you're dividing the money by the percent. You can't do it the other way around. Division's not commutative. That means it matters. The order you do it matters a ton. Okay, it's the price divided by the percent, not the percentage. Because here, if I divide 0.6, if you're dividing, I guess that's fine. But if you divide like this and you get something completely ridiculous answer like that, then you probably divided in the wrong order. Okay, on to the next page. 20% of my money is spent on my car payment. I make $3,000 in a month. How much is spent? I misspelled that. It should be spent. Okay, S-P-E-N-D-T. Spent, S-P-E-N-T. There should be no D. Instead of D, there's a T. Okay, let's read it again. 20% of my money is spent on car payment. I make $3,000 in a month. How much is spent on car payments? Now, this is not an off or up problem, so we're not going to go over here. We're going to put 100%. We're going to underline it. I'm going to use a percent that was given to me in the problem, and we make a proportion out of that, and it's called part and whole. Now, we want to define the part. Now, I've underlined what defines a part. Car payment. Now, let's circle the sentence. Got to go down here. Now, this is where X is in the sentence, I should say. This is the X. The sentence basically is the X. Now, does that say car payment in that sentence? You bet. So X goes here, and I know the whole is 3,000. I need to figure out the part I spent on car payments. So I cross multiply and divide. So I take 20 times 3,000 divided by 100, and that's 600. Okay. So $600. Okay, 30% of the people in town lived in an apartment. 2,700 people live in an apartment. How many people are in this town? Okay, so again, not an off-up problem, so I put 100%, and I'm going to put 30% over it. And this becomes because fraction is a part over a whole, P and W. Okay, now what's it say about the part? Lived in an apartment. Lived in apartment. You can abbreviate if you want, APT. That's what that means. Okay, now let's circle what we're trying to figure out. And you tell me, I'm going to read that sentence. You tell me if you ever hear anything about living in an apartment. How many people are in this town? And I don't think anywhere in that sentence they talked about living in an apartment. So the X will not be the part on this problem. It will be the whole. And then 2,700 goes on top. Okay, so we cross multiply and divide. I'm trying to figure out the whole myself. 100 times 22,700 divided by 30, that's 9,000. Okay, now let's say, don't write this down. Do not write this down. But let's say I accidentally misplaced the 2,700 down here. I'm going to show you what happens. So I'd multiply 30 times 2,700 divided by 100. I get 810. Now, you tell me, how can you have 810 people in a town and 2,700 live in an apartment? There's only 10 people in town. So you can't have 2,700 live in an apartment, okay? Okay, next one. 40% of the animals in the shelter were cats. There were 30 cats in the shelter. How many animals are in the shelter? Again, we want to use 100%, 40%, and then P and W. So the part is defined by were cats. Okay. How many animals are in the shelter? That's X. Okay. Now, remember the part. The part's the part that were cats. Let's read the question. You tell me if you hear me mention cats anywhere in there. How many animals are in the shelter? I never mentioned the word cats. So the X will not be here. It'll be here. And I put the 30 here because that's the part that were cats. So I cross multiply and divide. I take 100 times 30 divided by 40. I get 75. By the way, I'm not doing a very good job labeling these. 2,700 was people, so 9,000 would be people. And 30 is cats, but it's not 75 cats. It's how many animals. I mean, it asks how many animals. So you can tell by the question how it's labeled. Okay, 60% of the client. Let's look at the question to see how it's labeled. 60% of the clowns in the circus had red noses. This is a stupid problem I wrote. There are 50 clowns in the circus. How many clowns had red noses? So again, I'm using 60% over 100%. Okay, now we got part and whole. So part that had red noses. That's why I underline that so you know how to define the part. All right, now let's circle the last sentence. Now the part is red noses, and this is X here. Okay, does it say red nose? Are we in the sentence? How many clowns had red? Oh, it says red noses, so X must be here, and then 50 clowns in the circus. Okay, so I cross multiply and divide. Okay, so 60 times 50 divided by 100. I got 30. Now, if you're wondering about the label, it says how many what? Clowns. So 30 clowns. 30 clowns had red noses. There are 50 total or whole clowns. Okay, let's do some scientific notation now. Okay, I'm going to do one problem at a time. I'm not going to do it like I did in the last video. Decimals here. Now, you got to define the number from the beginning. Can't be a 0, though. 0, 0, 0, 0, 0, 3. Mark that. Now, I need the decimal to go between the 3 and the 7. To do that, I go to the right. See my decimal here? Looks like I'm going to the right to me. So that's right. That means we're going to have a negative exponent. So move it between these two. 1, 2, 3, 4, 5. So I got my point, and we have 3 in front, 7 behind. So 3.7 times 10, and then between the decimals, we got 1, 2, 3, 4, 5. But it's negative 5. Okay, if you want to check your answer, you take 3.7 times 10 to the negative 5th, and that 3.7 times 10, I forgot the negative. That's why it's so important to get that. And that's exactly what I started with. Okay, 6,700,000. First, you got to have a decimal. Well, you put it at the end if you don't have one. Now, from the beginning, find the first number that's not 0. Oh, there it is, 6. Okay. So I need the decimal to move between these two. Okay. So I will be moving this way, which will be to the left. So that will be positive. So 1, 2, 3, 4, 5, 6. So you got 6.7 times 10. It's a positive exponent, so I don't put the negative. Between these two, there's 1, 2, 3, 4, 5, 6. 6 places, okay? Think it's wrong? Punch it on your calculator. Okay, next problem. Don't have a decimal, it goes at the end. Now from the beginning, find the first non-zero right here. So it goes between that number and the number after it right here. So to do that, I'm going to have to move to the left. Okay, this direction's left. So left, and again, my exponent's positive. Okay. So 1, 2, 3, 4, 5, 6. Stop. So I've got 5.2 times 10. And I count the digits, so 1, 2, 3, 4, 5, 6. Okay, and that's positive, so positive 6. You want to check it, punch in 5.2 times 10 to the 6th. And that's exactly where I started at. Okay, next problem. Here's the decimal. Find the 0, 0, 0, 0, 0, 0. Boom, boom, right there. Okay. So it needs to go between the 6 and the 4. Now to make it go between the 6 and the 4, we got to trace this to the right. So right, that means my exponent's negative. Okay. Again, now the reason it's negative is because what you're doing when you move it to the right, you're artificially making the number bigger. So you tell, okay, that didn't make any sense. Disregard that statement. Okay, so 1, 2, 3, 4, 5, 6. So it's decimal here. There's a 6 in front and a 4, 7 behind. Times 10, because whenever I move the decimal, that's a power of 10 for every decimal move. So 1, 2, 3, 4, 5, 6. So it has to be negative though. Okay, 6.47 times 10 to the negative 6. Okay, there we go. Okay, next problem. Decimal, where's it at? Probably at the end. From the beginning, what's the first non-zero? Right here, so it has to go between the 7 and the 0. To make that happen, I have to move to the left. So left, so the exponent is going to be positive. So 1, 2, 3, 4, 5, 6. So point, and then we have 7 in front. Now, if there's nothing but zeros, lose the decimal. It's just 7 times 10. Now I count and it's positive, so I count the digits. 1, 2, 3, 4, 5, 6. 7 times 10 to the 6th power. Don't believe me? There it is. Same number as you started with. Okay, decimals here. 0, 0, 0, 0, 0, 4. So it goes between the 4 and the 2. And to make that happen, I go to the right. So I'm going to go to the right, which will mean the exponent's going to be negative. So 1, 2, 3, 4, 5. So point, you got 4.21 times 10. And remember, the exponent's negative here. So 1, 2, 3, 4, 5. You just count the total numbers between the two decimals. There should be no reason to use a calculator and to check your answer, backtrack your answer. 4.21 times 10 to the negative 5th. Okay, there it is. Okay. All right, don't have a decimal. Right here it goes. Now I find the first non-zero number. All right, there's a 4. So it goes between the 4 and the 2. So to move it there, I'm going to have to go to the left, which means the exponent's going to be positive. So 1, 2, 3. So I've got 4, 2 times 10. Positive exponent, 1, 2, 3, 10 to the third. Okay, here's my decimal. And first non-zero digit's 3. So the decimal must go between the 3 and the 6, okay? So to do that, we have to go to the right. Here, and I'm going to be moving to the right. Right, left, right. Okay, so right means the exponent's going to be negative. It kind of goes the opposite of a number line, okay? Usually we think of right as positive, but it's opposite, okay? So, got to be between here. So 1, 2, 3, 4, 5. Okay, so point, we got a 3, a 6 times 10, negative exponent, and 1, 2, 3, 4, 5, negative fifth power. All right, now this is easy. Scientifics to standard is simple. You just punch into your calculator. It's like you're doing what you usually do to check your answer, but this is the answer. 0.000273. Another thing you notice, you ever notice when the number ends up really small? That's because it was a negative power. Okay. 3.74 times 10 to the 7th power. That's going to be 3,740,000. Because what you're doing is it's moving the decimal back to where it was in the first place. 5 times 10 to the negative 5th, okay. And 8.3 times 10 to the 8th, okay. Okay, if you don't have a decimal, you need to put, don't put it at the end, but you want to put commas, 830 million. Okay, and I'm going to do these pretty fast in this other part here, okay. Original price of an item is $30. The item's marked up 20%. What's the new price of the item? Okay, the word up, you need to go add 20 to 100. That's 120%. Divide by 100, it's 1.2. Okay, so I make my formula, blank times blank equals blank, and we have original, percent, and new. Okay, so we know our percent's 1.2. Now go circle the last sentence and put your, I guess there's a little bit there, X variable. And you clearly see that in that sentence you're finding the new price. So the new price is X, and $30 is the original. Okay, multiplication, 30 times 1.2, $36, okay. Okay, items marked 40% off. Its new price is $48. Find the original price of the item. Okay, off means you have to subtract instead of add. You got to watch that. So that's 60%. Otherwise, you end up with, if you add accidentally, you get a screwed up answer. 0.6. Blank times blank equals blank. We have original, we have the percent, and we have new. Okay, so the percent we know is 0.6. So I'm going to circle the last sentence, X. Okay, it says original price, so X is the original. And $48 then is the new. All right, now I can't multiply, so instead I connect the lines, and I'm going to divide by 0.6. So 48 divided by 0.6. Okay, $80 was the original price. Okay, number 3. 70% of the town voted in the election. 200 people voted. How many people are in town? Now, there is no up or off here, so we don't mess around over here. You write your 100% smack dab in the middle, and you use that 70% over it. Okay? Now, remember what this means. PW. It's not anything to do with this. It's totally different. They're not even close to being the same type. So, okay, the part represents, I underline it, voted. I go underline the last sentence. That's our X. Now, does that say anything about voted? No. So X don't belong here. That's your whole. Okay? And the voted is 200. Okay, and you can cross multiply and divide. You have the part, you're finding the whole. So 100 times 200 divided by 70. Okay, I get 280. Round. Okay, you're talking people, so round that up to 286. 285 or 286, I don't care. Okay, because how many people? You can't have a decimal with people. You can have it for money, but not people. Okay, 4, 25% of the students in school are in band. The school has 240 students. How many students are in band? So you got 100%, 25%. Okay, P and A and W. The P is in band. Okay, circle the sentence. Put your X in there. Now read the sentence and you tell me if it says in band. How many students are in? Yeah, it does. So X goes in the part in band. And 240 goes beneath it. So I cross multiply and divide. So 25 times 240 divided by 100 is 60. Okay, it says how many students are in band. Well, now we know there's 60 students in band. Okay, scientific notation. Decimals here. First non-zero digits here, so the decimal goes between here and here. To do that, you have to go to the right. My pen is moving to the right, so right is negative, means the exponent will be negative. So 1, 2, 3, 4, 5. So point, I have a 4, followed by a 5 times 10, negative exponent, 1, 2, 3, 4, 5. 4.5 times 10 to the negative fifth. Don't believe me? Exactly the number you started with. Okay, decimal, where's it at? Well, at the end if I don't have it. Now go find the first digit, not 0 from the beginning. Right there, that'll work. So it'll go between that number and the number after 7 and 4. Now to have that, we need to move this decimal. It's got to go here. That's to the left. So left means the exponent's positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So point, we got a 7 and a 4 times a 10. Positive exponent, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the 9th power. Okay, next problem, decimal, right there. First non-zero is here, so it's got to go between the 5 and the 0. So that would be to the left, meaning my exponent will be written as a positive. Has to be. 1, 2, 3, 4, 5, 6. So decimal, 5 in front. If there's a bunch of zeros behind, lose the decimal. So times 10, positive exponent. Now just count the digits. 1, 2, 3, 4, 5, 6. 5 times 10 to the 6th power. All right, next one. Decimals here. Right there, okay, would be the place between the 3 and the 7. I would have to swing it to the right. So right means it's negative. 1, 2, 3, 4, 5, okay. So I got a 3 in front, 75 behind, times a 10. Count them. 1, 2, 3, 4, 5, but it has to be negative, okay? If it's a pot, you know, ready to be if I had to make that into the original standard number, and it will be that. Okay, and then the last part, last two are simple. Okay, write in standard form. 4.21 times 10 to the negative 7th. Boom. Wow, that's a lot of zeros. 0 point, and then we have 1, 2, 3, 4, 5, 6 zeros. And then 421. Okay, next one. 6.32 times 10 to the 8th power. I get 632, and then there are 6 zeros behind it. Okay, you don't put the decimal at the end, just leave the decimal out, but then you need to go put commas. So 632 million is the answer to that. Okay, having commas, remember, that's 1, 10, hundreds, and all these are thousands, 10,000s, 100,000s. Now we get in the millions.